For our second session, I would like to invite to our speakers that are Professor Jayesh Ruparelia. Can we please have them on the dais? He is the former head Chemical Engineering Department, Nirma University, Ahmedabad. He has obtained master degree and doctoral degree from IIT Bombay. He is working as a professor and has more than 25 years of experience. He is the formal head in the chemical department of Nirma University. He is a recipient of the Best Engineering College Teacher in Gujarat and Best MTech Thesis Guidance ISTE IPCL National Award for 2 consecutive years. Can we have a round of applause, guys? Our second speaker is Shri D.J. Yadav. He is the CEO of Arvind Envisol Limited, Ahmedabad. I request Shri Chirag Panchal to present Shri Jayesh Ruparelia with the memento and flowers. I request Sri Anash Sheikh to present the memento and flowers to Sri D.J. Yadav, who is the Director and Chief Executive Officer of Arvind Envisol Limited, at 100% subsidiary of Arvind Limited. Thank you. I invite Professor Jayesh Ruparelia for their speech.
Yeah, am I audible? Okay. Yes. Very good afternoon to all of you. Today in the morning, we have started the session with very good speakers, and that made my task very easy. Sunil Bhai told about global overview, where he said about this particularly the polluting industries and what is happening at the global level. In his talk, he talked about particularly the steel sector. Steel industry is the most polluting industry. There are a few more also there, but steel is the most polluting industry. Secondly, Devang Bhai, GPCB secretary, he told about this particularly about the Gujarat scenario. Afterwards, Deepak Bhai told about this particularly again narrow down to this Vatva industrial estate and the industrial level scenario, what is happening at the circular economy. Now, being a researcher, being a scientist, being a professor, what we are doing, what our, I can say, a little bit contribution towards the circular economy or betterment of the environment, let me tell you with a simple case study. So my topic is solid waste recycling, essential for the circular economy, a case study for the steel sector. Steel sector, why I have chosen particularly, that it's most neglected industry and again most unorganized sector. Compared to this, can say chemical sector or can say petrochemical sector, steel sector is most unorganized sector. Typically, again, Tushar Bhai is worried about the MSME. That what is happening with the MSME, no one is taking care of the MSME. So this particular, I can say, case study I have taken for the, I can say, MSME sector only, not the large-scale steel sectors, which they have afford to have the lot many measures to control or curb the pollution. So if you look at this particular global view of, can say, steel sector, per capita steel consumption, it's particularly strong indicator of the nation's economic development. Where India stands over here only 74.7, that is the only per capita steel consumption is there. Whereas you can say China is far ahead of us, Korea, Italy, Japan, etc. But very important thing for us to know about this particular sector is that government of India, what they are planning. they are increasing the per capita steel consumption to 160 kgs by 2030, 2031. So India is going to become a global manufacturing hub, and in that particular can say process, India is going to have from 74.7 to next decade, I mean in the next 10 years, or 8 to 10 years rather we can say, to 160 kgs, okay? Second thing, very important, I can say global current, what it reflects over here is that high correlation between the GDP growth and steel consumption that is observed across the globe for the various countries. Okay, here for example, you can say for China and Korea, two case studies are, I can say, presented on the slide, where this GDP as well as the steel consumption goes hand on hand, and both are increasing simultaneously. And same thing for India, because we are also expecting that the GDP is going to be increased tremendously in the coming decades. So it is expected that the steel consumption, steel related industries also going to contribute to this, particularly the GDP, and simultaneously to the pollution level also. Now coming to this Indian scenario, after global scenario, again Indian scenario is much needed for the steel sector. So steel and stainless steel industries production is around 14.5 and 5.4 metric ton per annum in particular the Gujarat. So you can see that various industries are there, okay, over here across the India. Majority of they are in particularly the Gujarat, Maharashtra also, and again eastern side of the India. Total capacity is around 125 million tons to process the steel, which includes the mild steel as well as the stainless steel. Now, here this industry is divided among the few integrated steel manufacturers are there, big scale industries are there, Tatas are there, Jindals are there, okay. So we are not talking about that. I am worried about, and my research is focused about this, particularly the MSME sector. MSME steel players, lack of the technical know-how on latest trends of the production, and particularly on the 3R, okay, that is the reduce, reuse and recycle. So particularly the most of the waste, okay, coming out from this MSME sector. Now, if you want to compete with this particular foreign players, that is from the China, okay, this MSME sector has to think in terms of the particularly the production capacity, production quality, the technology adoption, and ultimately very important thing is about their waste reduction or waste recycle, or particularly how they can compete with the circular economy or these big industries, those who are having a, can say, technical know-how for the circular economy. So how these particular things can be achieved. So now if you look this steel sector, okay, in by and large, okay, what is happening particularly that waste treatment and waste recycle is there. From where the waste is coming in? From the steel processing also, and particular steel manufacturing also. Now when the steel manufacturing is there, okay, they give this particular waste to the, their products, okay, to this steel processing, and from this steel processing we are getting the steel products. So it looks very particular, the entire process, okay, very nice. And whatever the waste is there, okay, we understand that is going for the recycling purpose, okay. So there is where to improve, where is a room for the improvement, okay, that is a big question coming in front of us. Now, if you see in the totality, if you see the cradle to grave approach for the particular entire steel sector, okay, we understand that it's not a good thing, okay, it's particularly the, I can say that proposing this particularly the grayish picture means that in terms of the environment, it's not good. So what is happening over here? Let's see the landfilling, okay. Low grade applications are there for the whatever the waste getting generated. So particularly the mill scale waste is there. Okay, it's having the particular more than 60% of the steel content, but it is going for this particular simply the, I can say, road construction landfilling kind of thing, not the landfilling in the secure landfill sites. Okay, so that kind of landfillings are there and they construct, but it's again a low grade application. Then particularly the steel processing industry, okay, the mill scale mill sludge and ETP sludge which is generated, which is also having the high content of the steel, which is not having these high grade applications. And when the steel manufacturing is there, okay, when we are talking about the steel manufacturing, the carbon is a significant, I can say, ingredient which is going to produce. So CO2 production is tremendously high. So if you see the steel industry's, can say, pollution level, okay, the steel industry is the third largest contributor to the air pollution. Across all industrial sectors, steel is particularly the largely contributing towards the air pollution. 1.83 tons of the carbon dioxide is emitted for every ton of the steel which is going to be produced. The outcome from the iron and steel making processing is the 8 tons of the moist dust, laden gases, 0.5 tons of the effluent water, and 0.4 to 0.8 tons of the solid waste which is getting generated. So there is a tremendous opportunity present in front of us to, we can say recover the, precious material out of that and then try to recycle it. The generation of the mill scale, which is the particular the target for, I can say, my research, okay, that mill scale represents about 2% of the steel produced. So whatever this mill scale is there, okay, that is produced, can say that per ton of the, consider the per ton steel produced, 2% of the mill scale getting produced. In the past years, the steel maker used this mill scale as an oxidizer in the conventional electric arc furnace, in a particular steel making process. However, the modern electric arc furnaces are equipped with the oxygen and particular lessing system. So that particularly the application is also, vanished. So ultimately they are just diverting their mill scale waste or mill sludge waste into this particular the road filling kind of activities. So if you can think about this particularly that cycle, okay, which is happening in the steel sector, which is not good for the environment, not good for the circular economy, what is to be done? So we just reverse this arrow particularly, which is going steel manufacturing to the mill waste, okay. We are trying to reverse, okay. So ultimately we are trying to get this waste recycled into the steel manufacturing itself and trying to green this particularly the steel manufacturing process. So here, which are the options in front of us? So for the waste recycle, to produce the DRI, direct reduced iron, and steel from the mill scale and mill sludge. We can directly produce this particularly the mill scale from the mill scale and mill sludge directly producing the steel. Second, in the steel manufacturing, how we can do? So ultimately we can go for the decarbonizing the steel manufacturing by using this hydrogen, okay? By just eliminating whatever the carbonaceous fuels are there, we can totally eliminate and just use the hydrogen based fuels so that we can reduce this carbon dioxide production. And then finally, steel processing. So again, here in steel processing, that is also one of my research area. We are working on that and we got very good success, but right now today, I'm not going to discuss that. So in steel manufacturing, what is that particular, when the steel manufactured, okay, that is a particular oxide layer is there that is removed by pickling process. The pickling process, probably all of you studied in school days, it's particularly we are putting these steel sheets or steel products into the, concentrated acids like sulfuric acid is there, nitric acid is there, and then try to remove the upper layer. And then as a return, we are getting this particular finished product. But what happened to the steel, what happened to the acid? So now that acid remains and that acid is particularly creating the problem. So lots of sludge getting generated. So what our target is that acid-less pickling. We have just developed this particular process in a laboratory. We are just having a trial and the industrial scale also, where we are totally eliminating this particularly the acid from the steel pickling process and then eliminating the usage of the steel. So there is no question of the any sludge which is getting generated. So this is the way by which we are targeting this greening of the steel manufacturing process. Coming to this, today's topic about the waste stream which is getting generated and how to produce this particular direct reduced iron. If we produce direct reduced iron from the waste itself, because I'm not informing you about the steel to be recycled, I'm informing you about the waste. There is a mill scale, there is no usage, okay? How to recycle by making directly steel out of that, and these particular things are the research topic for me. So you can see this particular manufacturing process over here. The raw material is there, either electric arc furnace or blast furnace is there. From there, we are getting the LD converter, secondary refining, continuous casting, hot working, and cold finish. These are the, broadly we can identify the flow diagram for the steel manufacturing process, in which these are the particularly the various steel related byproducts or waste which is generated: slag, sludge, dust, okay, mill scale, mill sludge, okay. These are the waste which is getting generated, and usually there is no takers for that. So my target is this waste material which is available in the steel industry, and then we are trying to catch up. If you look at the certain data points for this waste particular material, okay, so waste material accumulated, which is known as the mill scale, is around 25 to 40 kg per ton of the steel which is going to be produced, and mill sludge is around 12 kg per ton. Predominantly, this contains the elemental iron and oxides of iron. So what the mill scale and mill sludge contains? So it's particularly, you can say that most of the part is particular oxides of the iron only, okay. It is estimated that over 13.5 million tons of the mill scale waste were being produced annually, translating about this 2% of the global steel production. So whatever the global steel production is there, that can be fulfilled, 2% can be fulfilled if we can just recycle the mill scale. The iron content is normally in the range of 70% in mill scale, and particularly around 50% in a mill sludge. So 70% of the iron content is there, and we are just putting into the lower grade application. My target is to use it for the higher grade application so that the circular economy can be attained. So we have visited one of the, I can say, industry and then identified that how this mill scale is produced. We have taken the samples of that. So it's a mill scale generation cycle. It's a hot rolling mill. Okay, from the ingots they are making the rods, pipes, seats, etc. Okay, so whatever the upper layer is there, you can see the black layer which is generated in presence of high temperature and in presence of the oxygen in the presence of air. Okay, this is converted into the mill scale that is to be removed, and then you can say big, you can say hips of the mill scale that is there in particular steel processing industry. So objective is to develop the steel waste recycle process which is efficient and implementable by the industries to enhance the circular economy. That was the innovative things which we are targeting. So quickly I'm just running through the materials and methods part for this particular research work. So we have taken this particular mill scale, putting into the furnace, and then with the furnace we are putting, inside the furnace we are putting certain, you can say, fluxes, various chemicals we are putting based on our, you can say, research, that these are the chemicals can work nicely with this particular scale, and they try to reduce it at the high temperature. So taking this furnace temperature around 1600 degrees centigrade, then cooling the particular metal part, then we are trying for the analysis for the, I can say, XRD analysis of this particular steel which is getting produced, and then finally we can just modify our, can say, flux. So it's an iterative process. Continuously we are putting different, can say, combination of the fluxes, then trying to melt it, trying to find out the particularly what are the results, and then again coming back to this particularly the initial part. So in that our basic, you can say, scientific base, okay, was that Ellingham diagram, in which we identified that in Ellingham diagram, in presence of carbon monoxide, whatever the oxides are there, that gets reduced. So various, you can say, oxides are there, and we can find out that the typical, can say, oxide of chromium oxide is very hard to reduce, okay, in presence of any of the materials. So we tried various combinations and try to generate the carbon monoxide inside this particular furnace at 1600 centigrade temperature. So here we got this particular point, and we identified the various reactions going on further. I'm not going into much detail of this particular thing, but we identified that we got few success over there. So these are the lining materials. Now, again, when it is a research and development, when there is innovation, when there is a uncharted path is there in front of you, we always get the failures. So we also got the failures. So just I'm highlighting my failures also in front of you. So this is a furnace, the lining material is there, and we have this particular copper coil, okay, for the induction heating. And then there is an outer casting. We are just doing this particular experiment in the industry. So when we had done the industrial experiment, okay, we got this particular success, that whenever the charge is ready, we got this particular temperature is to a certain level, we get the carbon monoxide formation, and then when excess carbon monoxide is released, we get this kind of flame from the furnace. And then particularly temperature is reached, and then finally we are just discarding the liquid metal out of that. Whatever the material is coming out of that is a reduced mass. We have taken, okay, the lump, and then we have tested for the further analysis. The grinding test is there. We have done the XRD, XRF test also, and we got that the particular material is getting reduced. But now what happened that it's not, again, we have to think that whether it is implementable by the industry or not. So when we think, okay, we got the success, it's a eureka moment for us. But what happened that we observed that the lining material from the furnace, okay, that is get eroded. Okay, what happened that lining material got damaged because of whatever the chemicals we have put inside the furnace to react with this particularly the mill scale waste, it is reacted with the lining material also. And then what happened, the lining material started. So after each run, it is not possible for the industry to replace the, you can say, the lining material. So we have to work on that. So what we identified as a solution, okay, that we can take up this particular the graphite crucibles, okay. So we have taken the graphite crucible, inserted inside the furnace, okay, and then carried out this experiments again, okay, so that we can just, you can say, secure our lining which is there inside the furnace. So again, the experiment has started. Now again, what happened that we identified that after second or third year run, okay, we observed that the bridging related problem appeared. Now what is that bridging? That particular is one sort of this furnace is one sort of reactor only. Okay, those who work in the particular industry, they understand that the reactor always requires this particular the uniform, okay, say uniformity inside the reactor. It requires continuous mixing, continuous agitation is required. Now again, it's a high temperature. Again, the liquid mass is particularly very dense, so there is no mixing is there. So as a result, what will happen? The liquid is that heat is not transferring throughout the liquid mass, and this bridging takes place. So upper part remains the cold zone. bottom part, okay, where we are getting the heat from the surrounding side and from the bottom also, it's properly heated and reduced. But what happens that in between there is a bridge which is not converting that, not conducting that heat to the topper layer. And as a topper layer remains as it is, without reduced, and it remains as it is, that is called the bridging problem. So we have observed that bridge, okay, you can see over here that I can say liquid and semi-solid that's coming out, and the bridge is clearly observed in the particular furnace. So again, issues are there. We couldn't find out that what to do with that. So again, after studying the literature and as on particular study, okay, what we identified that we can make these pellets, okay. So once the pellets, it's a dense material, we are just putting the, can say mill scale as it is, okay, and with the particular chemicals and putting inside the furnace. Now we have, I can say, taken this one pellet machine, okay, and then trying to make the compact, I can say, mass of the mill scale, and then trying put inside this particularly the liquid pool. So initially we take up this liquid pool, half filled, then putting the pellets one by one. So frequently we have to open the furnace and putting inside that. But by doing so, we are getting this success. Okay, no doubt it's not yet implementable or acceptable by the industry, that we know very well. But again, first and foremost thing is what, that we have to prove the concept. Second thing is that we have to demonstrate the feasibility, technical feasibility. Economic feasibility and you can say work-wise feasibility comes later on, but technical feasibility has to be proven. So this technical feasibility has been proven in the particularly industry. So with this, I can say that we got certain success over here for the recyclability of this particular chemical, the mill scale waste towards the higher grade application, okay, not the lower grade application. When you go for the higher grade application, obviously you can get the good, you can say, return out of there, or whatever the waste material is there. So to conclude my talk, okay, what I can say that this research is depending upon the support from the industry. The entire work need to be carried out in the industrial premises, because I am working in the university. Saturday, Sundays I have to go to industry, carry out the work. Again, Monday to Friday working in the particular university for my, can say, academic loads, research work. So it is again a time-consuming process. No doubt, I say that when I got the funding grant from the Gujarat Council of Science and Technology, Gujcoast, okay, they have granted, and at that point of time I said that, sir, my, can say, research work is in the industry, not in my university, so it will take some time. They agreed and they have supported me that, okay, you will take your time, but complete this research as per your time frame. Prima facie, the reduction of the mill scale takes place as represented by the grinding of the lumps and the, can say, analysis of materials carried out by XRD, XRF. And very important thing in this forum, what I would like to highlight, that whatever research carried out, okay, Tushar bhai has rightly pointed out that I can say invention is required, research is required, okay. But again, alone with the industry, it is not possible. Alone, academia also cannot do it. Alone, I can say government also cannot do it. Trio of these three together, the industry, academia, and government, they can come together, because government is needed for the giving the grants or giving this particularly the bypassing some rules, okay. Just sometimes it is required. Like in Vatva, they are facing the issues of the spent sulfuric acid. But at that time, the hazardous waste management rules came into the picture, and GPCB has taken this active role, and then they have given this particular some immune, okay, in front of the rules, and then slowly it become the change of the rule also. But initially, when we particularly the research is going on, that kind of, I can say, support from the government is required. Support from the industry is required in front of academia, is that industry has to open up and give the live problems to these, I can say, academics, and also give some time to solve the particular problem. So collaborative efforts from industry, academia, and government are must to achieve the goals of the sustainable development and a circular economy. With this, I end my talk, and I thank Mr. Dharmendra and team Saket Projects to give me opportunity to present my work over here. Thank you very much.
Thank you, sir. Moving ahead, I now invite Shri D. J. Yadav to deliver his speech.
Good afternoon, everybody. Circular economy actually is a very old concept, especially in our country. I'm sure at one or other time, every one of you at home or at your office or at your factory, you must have done something which falls in the definition of circular economy. The reason is sometimes it is necessity, that you have some problem and you end up doing some circular economy. Sometimes it's your innovation kida into you, where you want to do something to, showcase that, I've delivered something. Sometimes it is the business pressure, it is the pressure of, delivering the higher profit or sinking profit, you want to come out of it. You must have done that. For example, as my predecessors, Mr. Jani has said, that in our old times, the elder brother's shirt will go to the younger brother's shirt will go to the even younger brother, then it will end up into pota, or you will sell it to someone, your mother will sell it to someone and buy the vessels and so on. So that's one example. I was also fortunate at my organization at Arvind Limited way back in 1997. So I am originally a mechanical engineer and a power plant experienced person for 16 years. In 1997 at Arvind, we set up a very huge facility in Santej. It's a 490 acre, one of the biggest textile plant in one location. And one of the major problem was the water, because there was no discharge point available there. And that necessity forced us to build a zero liquid discharge facility. Now, zero liquid discharge, otherwise there was no regulation at that time to do the ZLD, which is a very popular word today. But we were forced to do this, and also the Lalbhai Group management is known for doing something, before anyone else does. So we set up a zero liquid discharge plant, and I was asked to look after that plant, though I had no background of, water. And when we run this plant and when we saw the amount of water that time, that plant was designed for 1 crore liter per day, and it was operating at 80 lakh liter per day. And that much amount of water, if you go up and see it, it looks like a small river. And we had a tremendous pressure to stop this plant because of the cost pressures, because the conventional treatment system will cost about 6 to 7 rupees a meter cube that time. This plant was costing us almost 450 rupees a meter cube to recycle every drop of water, of course. There are a lot of value into it, but there was no proper pricing into it. And hence there was tremendous pressure. But when I saw this plant, I thought we should not stop this plant, because 80 lakh liter every day you extract from the ground and you throw it somewhere after doing primary, secondary treatment, and it will end up in damaging even huge quantity of water down the line, or it will spoil the land and so on. So that is where the circular economy sustained because of the passion of my own and my very good, excellent team that time. That we worked and we made this plant efficient, cost effective, and so on. So we must have bleeded that time to do this circular economy project that time. But down the line, after 10 years, when things become common and recycling became common, the huge experience that we gained to run this plant for so many years actually enabled us to start a water recycling business, and today we are running a company having more than 500 crore turnover to do the recycling of the water. So it is, at first sight you may feel that, the thing is very costly, but in long run it will always pay off, is the message I wanted to give. Another small example that time, how the circular economy worked, is that we had a small pharma company adjacent to our boundary of this thing. And he had heard about this huge plant. So one day he came and requested my manager that, I have a plant here and GPCB has given me a closure and I have only 5,000 liter a day. So can you treat it for me? So 1 crore liter plant, we were operating at 80 lakh liters. So we had capacity and we had tremendous amount of cost pressure. So I said, okay, let's try it. We will earn some money. Apna cost pressure kam hoga. So my chemist went and brought the sample and did the testing, and he realized it's not merely effluent water. It has some qualities, and when he did some test, he found that it is removing the color in my textile effluent. So he came and he said, sir, ye to kuch color removing chemical hai. And when we went back to his factory and they studied, they found it was PAC, polyaluminum chloride. And we started that 5,000 liter as raw material in our plant. And later on at various platforms, we started talking about it, that this is how the waste of one industry can become a source or raw material for the other industry. We published it, and I think today in a big way, the PAC is being used for treatment of the water. Similarly, our water is alkaline. There is some acidic water coming out from some stream. Instead of using virgin HCl, we use acidic water of other industry to neutralize our water. So we had been doing this in bits and bits, but today it has come in a different package, and it has come at a stage where, at a state level and at country level and at global level, we have to talk about it, because we have allowed the environmental damage to happen to such extent that, we can't anymore ignore it, and our efforts to do this in tits of bits has to change to do it in more scientifically and more bigger way. So a lot of examples have been given, what is circular economy, how it is done, there are case studies done. I only wanted to highlight that each one of us can do it. Each one of us, whatever activities we are doing, we have an opportunity to implement this concept, and it will benefit not only you and your business, but it will benefit the society as a whole. And it is need of the time to do this. So some of the significant things which I want to put on record today is it's really not a problem alone. It's also an opportunity. So more than 100 billion tons of resource get used in the economy every year, and only 8.6% of it is being recycled. So you can imagine the various business opportunities available in this field, where you can, put up a facility, put up a concept where you can make a lot of money out of it. And that can, the other benefits can be the byproduct of it, which you can be also proud of. At this rate of consumption, they said you will need about 2.3 times the planet what we have today by 2050. If the consumption level goes at this rate only, because we know that consumption rates are actually going up. So we are surpassing the capability of the earth to, regenerate the resources against the consumptions that we do. So it's a very alarming situation. Shifting to a circular economy where we can reduce, reuse, and recycle can decouple the world's growth from the consumption. So that's the key, that we all need economy to grow, we all need to flourish economically, but at the same time it is mandatory, or it is inevitable, that we survive and we live a good and healthy and happy life. So to decouple this concept has become mandatory today. A push for circular economy or circularity can create jobs and reduce the waste and carbon emissions. So these are the other benefits that I was talking about. Let's give an example. The small thing which I have said, if you look at globally, in textile industry, other than the resources that we use like cotton and other thing, we use almost 100 billion cubic meter of water for textile processing. And approximately 4% of fresh water of the global consumption goes into this, which is a huge quantity which goes only in single industry as a fresh water. So that signifies how important it is to conserve or recycle this very precious natural resource. Against that, it's not only water recycling, but how do we use clothes? People throw away clothing parts, which are still useful, together up to a value of estimated $460 billion per year. That much amount of valuable, not only resource, but converted product is being thrown away. જે મેં કીધું શરૂઆતમાં કે શર્ટ મોટો ભાઈ નાનો ભાઈને એ જે વાપરતા હતા, that doesn't happen anymore. So that much amount of waste is, resource is wasted, and then there are damaging effect of it because you have thrown it in an unscientific way. of every 100 used clothing parts, 85% of which can be, recycled and made as a new part. So that's the opportunity, that's the possibility available to generate wealth as well as to generate health and to generate the, to save the natural resources. So this quick chip fashion change which occur, if that stops, I think there can be a significant saving only on this front. Similarly, we talked about plastic. 300 million tons of plastic is, we produce every year. And other 54 million tons of electronic waste, all our computers, mobiles, and so on, out of which only 17.4% are collected, and only partially of that is being recycled. So you can imagine amount of dumping that we do of these things. A US $13 billion in cost and economic losses every year due to plastic waste happens. So it's a huge, huge waste which is occurring, which is quite possible to, avoid. It has a job opportunity, as we know how many rag pickers we have in our own city. So we also do plastic collection in our business, and when I saw them, hundreds of them every day come and take cash money by giving the plastic to us. So it's a job opportunity. Already 15 million people in the world are there as a collectors. This, and as I said, we are only doing this job partially. So there is a job opportunity much bigger available there. And the circular economy in one of the reports says 401 trillion euro opportunity is there in different ways to do the business in this. And to materialize them all, we demand ambitious action. So in tits and bits, as I said, we all do. But now is the time when we have to do it in proper coordinated way, proper use of technologies, proper policy framework and everything. So we have to do it in more scientific way than what we had been doing. So for that, government, companies, civil societies, financial institute, researching organizations, all of them have a role to play. Because if you say government, the policies, as people face problem in collecting the waste, people face problem in collecting the sewage water even, people face problems in transporting the hazardous waste from one place to other place. We remember when we started co-processing in Gujarat, there was huge, like PAC. When we started doing that, there were a lot of problems from GPCB that you can't transport it. But when we went, when we pursued and we showed them the value available it, and we showed that actually it serves your purpose of avoiding the pollution, and then it became normal. Co-processing happened. So we can graduate to that, but we have to work hand on hand with all the pillars of this society to do that. The companies, resource consumption, production efficiencies, recycling of waste and so on, where companies also have to contribute in a big way to, use and generate the new technologies to do all this. So I think all of you know what role they have to play in how they can play this role. So as I said, creating a circular economy is actually an opportunity. It is actually strengthening the local economies in a socially inclusive way, because everybody can be part of it and everybody can reap the benefit of it, right from rag pickers to big businessmen. It creates far more jobs than taking the traditional linear approach to the waste, because you just take it and dump it somewhere. Instead of that, when you recycle the same waste, there are a lot of more agencies, more people who have role to play and who get the job and money out of it. So compared to linear, it has a lot more job opportunities available. Enhancing circularity is an efficient level to help the society to reach to the net zero. India talks about net zero by 2070, and I don't think it can happen without adopting the circular economy in all our aspects of operations. Bring our economy more into line with the Earth's boundaries, and circularity is also clearly a nature positive, which I think all of you will agree. So, circulatory is for the better future because it makes better use of finite resources, it reduces the emission, it protects the human health and the biodiversity, it boosts the economy and creates more and better job opportunities. I think these 5 points, covers everything that circular economy can deliver, and nobody can deny that why it should not be adopted in any of the areas that we are into, right from home to factory to office. Thank you very much. I think, as someone said, each one of us have to take this on us instead of saying that government should do this or companies should do this. I think in each walk of our life, if we start seeing that nothing goes as a waste, if we start saving the resources right at, I call it as the beginning of pipe solution. So when you start using a resources there itself, if you can avoid the waste and use it more efficiently, I think the actions remain to be done in rest of the part will be very less. So thank you very much for this opportunity, and let's join hands together to walk on this path which is good for every one of us. Thank you.
Thank you so much, sir. Now I request Joshi sir to provide the audience with the closing remarks.
બિફોર ધ ક્લોઝિંગ રિમાર્ક્સ કોઈના મનમાં ક્વેશ્ચન્સ આવે છે? આમ તો ભૂખ લાગી હશે કદાચ, એવું માનું છું. ઇટ ઇઝ ટાઈમ. Once again, both of them experts. Dinesh Yadav has been with us for almost all the conferences. He has been one such person whom whenever you call, he would never say no. And you always get a lot of inspiration, a lot of information, a lot of knowledge from what he says, because it has been his own life experience. Like he said, although being a person from the power sector, when he shifted from the power experience into the waste management experience, particularly water waste management, and now I was just talking to him, he is also entering into plastic recycling with a company. That experience has given him a lot of exposure, and he likes to share it with the members. So I take up, two things from his talk for all of us here when we are talking about circular economy. One, 4.1 trillion euro opportunity. 4.1 trillion euro opportunity. 1 euro is almost like 100 rupees as on date. You can convert. It's a huge opportunity in this sector. And people here, maybe you consider yourself only to be into a waste management sector, but for you the future is how you can, like he shifted from power to waste management, you shift your focus from just being a waste management professional to becoming what would in time be known as a circular economy professional. હજી આપણે એ શબ્દ સાંભળતા નથી, but it would come. You specialize in innovations. You specialize in doing something different which would save resources. That's what I believe, one thing which he said. And along with that 4.1 trillion euro, he said it's a 6 million job opportunity. 6 million job opportunity. Even if we get 10% out of it in India, it's huge. Every one of us has a, bright professional future, but of course, with the changed mindset to use resources to the minimum and convert from linear economy to circular economy. Jayesh bhai, the steel industry was just an example. It was his experience, his research that he mentioned about steel economy. But the same idea, same principle, same approach works for any industry here. And one thing which was very, very prominent that he said in the end was industry, academia, and government need to work hand in hand. All of us here from the industry, a lot of people from the government, and people like him We need to join hands. Industry needs to go to the institutions to find solutions. They need to seriously work on feasible solutions of the industry. And of course, like he said, the government needs to facilitate such kind of a joint approach or a joint effort by connecting the right industry to the right kind of people in the academia. Then I believe that part, industry, academia, government collaboration would work better for the industry. Research, of course, it is very important. Unfortunately, in our country, we do not give too much stress or importance on research. But research and development needs to be funded or supported by the industry and facilitated by the government. Government may put in seed money to set up, testing laboratories or something of that sort. However, your particular industry research has to be funded. We need to come up with a little bit of money to be given to the academicians for developing solutions which are customized for us. Like I was talking to him, Naroda, Vatwa, and a lot of other places have a lot of steel rolling mills. All of them, if they come together, like the people in CETPs have come together to offer solutions, if those industries as a cluster come together with one solution that he can provide, the cost of that solution, maybe the cost of the research, can be shared by all those industries, and then it would maybe become feasible. Circular economy, when we go forth, it is going to bring in a lot of value in terms of money also. How? Because you will not only reduce wastage, however, a lot of your byline or byproducts will bring you a lot of money, like gypsum. So that is how we all will be able to control our costs that are going up. And those costs controlled is indirect profit generated for the company. And in terms of a whole economy, it means a huge lot when we talk about value of the rupee of Indian economy. I believe this is the takeaway from this session. Let us all once again resolve that we will do our bit together for this country, this humanity, this world that we are living in for the future generations. Thank you very much, Mr. Yadav and Professor Jayesh Parelia, for sparing your valuable time and sharing your knowledge, your wealth of information with our participants. And I'm sure they would take it very seriously. They would have taken a few more points to note and learn from your talks. Thank you very much once again, friends, for being here. And let us break for lunch. We are about 45 minutes late. So let us, try to save that 15 minutes. That is also circular economy, saving time. So let us, reduce our lunch time from 60 minutes to 45 minutes and be back here in the hall at 2:15 p.m. Thank you very much.